In this video, we're going to take a look at the concept of inheritance. Now, inheritance is the process by which one class takes on the attributes and methods of another class. And this is a very good way of being able to reuse features across classes without having to repeat function definitions, meaning we can stick to the dry principle and not repeat ourselves. Now, newly formed classes which inherit from another class are called child classes or subclasses. And the classes that the child classes are derived from are called parent classes or base classes. Now, what this means is that we can create a child class, and this child class can then override or extend the attributes and methods of the parent class or parent classes, without us having to rewrite all of the attributes and methods again. In other words, child classes inherit all of the parent's attributes and methods, but can also specify attributes and methods that are unique to themselves. So to summarize, inheritance refers to defining a new class with little or no modification to an existing class. The new class is called a child class, and the one which it inherits from is called the base or parent class. So let's take a simple example. Imagine you have created a dog class and have created a few methods. For example, we have created an eat method, a play method, a sleep method, and a bark method. Now imagine that you create a new class which pertains to a specific dog breed. Let's say a poodle. We know that a poodle eats, it plays, it sleeps, and it barks. So we can have it so that all of the attributes and methods of the dog class are inherited by the poodle class. Now we may want to be a little more specific with the sound that a poodle makes when it barks. Now if we wanted to override the bark method of the dog class, we can do so in the poodle class, which means that the bark of a poodle is more unique and is specific to the poodle itself. The other methods can stay as they are, which means we have inherited the methods but have overwritten the bark method. Now let's take this over to Jupyter Notebook and see it in practice. So let's pretend for a moment that we're setting up a doggy daycare. And we know that when we look after dogs, the dogs could be of different breeds and they could all engage in different behaviours. Now let's suppose that we want to model the doggy daycare with Python classes. The dog class that we wrote in the previous section enables us to distinguish the dog by its name and its age, but it doesn't allow us to distinguish the dog by its breed. Now we could modify the dog class and we could add a breed attribute. So let's go ahead and do this. So within the init method, we can put a parameter called breed, and then we can have self.breed equal to the argument that's passed in to the breed parameter. Which now means that when we create an instance of this dog class, we're now expected to input 3 pieces of information. So let's now create 4 instances of the dog class. We'll create a dog called Dolly, and we'll set this equal to a call on the dog class, and we'll pass in the name as a string Dolly. Dolly can be 7 years old, and Dolly is a Shih Tzu breed. We'll create a dog called Flo, call upon the dog class, pass in the name Flo, age 9, and Flo is a Dachshund. We'll create a dog called Sassy, equal to a call on the dog class, where we pass in Sassy, who is 3 years old and is a poodle. And we'll finally create a dog called Betty, and we'll set this equal to a call on the dog class where we pass in Betty. Betty can be 1, and Betty is a frog. Now inside of the dog class, we've created a method called speak, which takes in 1 argument. So if I wanted Dolly to speak, I could put dolly.speak, and then I can pass in yap. When I run this code cell, you can see that we return to the screen, Dolly says yap. If I wanted Flo to speak, I could put flow.speak. I would need to pass in an argument, so let's put woof. and when I run this code cell, we return Flo says woof. Now we know that different dog breeds sound different when they bark. Some have high-pitched barks, some have lower-pitched barks. But if we just use the dog class, we will have to supply a string as an argument to the sound parameter every time that we call it on a dog instance. But this isn't very efficient. If we know that different dog breeds have different sounds when they bark, we should simply be able to call upon the method speak, and depending on the breed of the dog, the respective bark sound would be made accordingly. Now this is where inheritance can make our lives a whole lot easier. What we can do is create a new class for each breed of dog which inherits from the dog class. Now this will allow us to access the attributes and methods of the parent class, in this case the dog class, and it will also allow us to extend the functionality that each child class inherits, which in this case will be different breeds of dog, including specifying a default argument for the speak method. So I'm going to copy and paste the dog class that we've created above, and I'm going to remove reference to self.breed equals breed, because we don't want to have to pass in a breed name every time that we create an instance of a dog. What we will do is create a class for each breed of dog. So we can put class, and the first breed will be Shih Tzu. We can then put parentheses, and then inside parentheses, the way we inherit from a parent class is by passing the parent class's name into the parentheses. So I can put dog inside parentheses, which refers to the dog class that we've created above. We can then put a colon, and for the time being, I'm simply going to put the keyword pass, which essentially acts as a placeholder, and our code will run without running into any errors. We'll then create a class for the Dachshund. We'll do the same for the Poodle. And we'll create a class for the breed Frog, which once again inherits from the parent class dog, and we'll use the pass keyword accordingly. Now with the child classes now defined, we can now instantiate some dogs of the specific breeds. So where previously we passed in an argument for the specific breed of the dog, we can now copy and paste the 4 instances that we created above, and we can modify them accordingly. So for Dolly, we know that Dolly is a Shih Tzu, so we can call upon the Shih Tzu class, which we know takes in 2 arguments, one for the name and one for the age, so we can remove reference to the breed specifically. We can change Flo to be a call on the Dachshund class, and we can remove the argument Dachshund. Sassy will be a call on the Poodle class, and we'll remove the argument Poodle. And finally, Betty is a call on the Frog class, and we'll also remove the argument Frog. Now, as mentioned previously, instances of child classes inherit all of the attributes and methods of the parent class. So if we were to call upon the kingdom attribute on the instance called Dolly, so dolly.kingdom, you can see we return animal. Even though the Shih Tzu class doesn't have any specific attribute or method defined inside the class, it's inheriting everything from the dog class. If I were to put the built-in function print and then pass in the variable Flo, you can see we print Flo is 9 years old, and that's because inside the dog class we've overwritten the dunder str method, and we return this sentence accordingly. Now if I wanted to determine which class a given object belongs to, we can just use the built-in type function that we've seen before. So if I put the keyword type and then pass in sassy, what do you think will be returned? Well, if I run this code cell, you can see that we get dunder main dunder, then a dot, and then we get reference to poodle. And this is telling us that the variable sassy is of the object type poodle. So sassy is a poodle. Now we know that sassy is of the object type poodle, but what if we wanted to determine if sassy is also an instance of the dog class? How do we go about doing this? Well, we can use the built-in isInstance method and pass in the respective objects. So if we wanted to see if Sassy was also an instance of the dog class, we could put isInstance and then open parentheses. We can then put the object that we're looking to test for, in this case it's Sassy, and the second argument will refer to the class that we're seeing if Sassy is an instance of. In this case, we'll put dog. So is Sassy an instance of the dog class? When I run this code cell, you can see we return true. And if I were to check to see if Betty is an instance of the poodle class, and we know that Betty isn't, we know that we've instantiated Betty by calling the frog class. When I run this code cell, you can see we return false, just like expected. So with the 4 instances that we've created above, i.e. Dolly, Flo, Sassy and Betty, we know that they are all objects and are all dog instances. But Flo is not a frog instance. Flo is an instance of the Dachshund class. Sassy isn't a Shih Tzu, Sassy is a poodle. So if I were to summarize this, I could state that all objects created from a child class are instances of the parent class also, but they may not be instances of other child classes. Okay, so we've created some child classes for different dog breeds, and we've instantiated some objects accordingly. But let's now give each breed its own sound. So in the next video, continuing on from this video, we're going to see how we can extend the functionality of a parent class. So I'll see you in the next video.